Hi everyone, this is your math guru. In this video, I'm going to show you how to simplify the following sort of expressions. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. As a quick recap, the rule of Surds states that if we have the root of a times b is the same if we write it as the root of a times the root of b. This also works for a division. If we have root of a divided by b is the same as the root of a divided by the root of b. So going back to our examples, in the first example we have root of 12 plus root of 48 minus root of 27. So simplify, we need to change each root or rewrite it as a product of any of its factor pairs. However, in doing so, we need to make sure that at least one of the factor is a perfect square. So therefore, to rewrite 12, we are going to use 4 times 3, because 4 is a perfect square. We can easily find the square root of 4. We have for 48, 48 is going to be the product of 16 times 3 minus for 27, the factor pair we will use will be 9 times 3. If we split this up, it's the same as the root of 4 times root of 3 plus the root of 16 times, my dots represent my multiplication sign, root of 3 minus root of 9 times the root of 3. We can find the square of each of the perfect square highlighted, such that we have root of 4 to be 2 root 3 plus the root of 16, that's 4 root 3 minus root of 9, 3 root 3. Therefore, we all have similar roots, that's root of 3. So therefore, we can easily simplify. We have 2 root 3 plus 4 root 3, that will give us 6 root 3 minus 3 root 3, that's 3 root 3, and that's our answer. For B, we have root of 162 minus root of 32 plus root of 2 minus root of 50. Like we did in the first example, we have to rewrite each root as a product of any of its factor pairs, making sure that at least one of the factor is a perfect square. In this example, we can use a root 2 as a guide, because that's root 2 is already an irrational number, so we're going to leave it as it is. That will guide us in finding the factor pair of each of the following surds, such that we have 162 being split up into 81 times 2 minus 32 will be 16 times 2. Remember, like I said earlier, I'm using my root 2 as a guide. And then I have 50 being 25 times 2. If I split that up, that will be root of 81 times square root of 2 minus root 16 times root 2 plus root 2 minus root 25 times root 2. In each of these terms, we have a perfect square. We have 81, 16, we have 25. Simplifying, we have square root of 81, that's 9. We leave our root 2 as it is. We have square root of 16, that will be 4. Root 2 plus our root 2 remains the same, minus square root of 25, that's 5 root 2. Note that they all have the same root, that's root of 2 in the same set form. So therefore, simplifying, we have 9 minus 4, that's 5 plus 1, 6, 6 minus 5, 4. I'm going to do a double check on that. I have 9 minus 4, 9 root 2 minus 4 root 2, that will give us 5 root 2 plus 1, there's an invisible 1 here, 1 root 2, that's 6 root 2 minus 5 root 2, we're left with 1 root 2. So our answer is 1 root 2 or root 2. Let's look at our last example. In our last example, we have root 18 plus root 8 minus root 72. Rewriting each surd as a product of its factor pair and making sure that at least one of the factor is a perfect square. I have 18 becoming 9 times 2 plus 8 becoming 4 times 2 minus I have 37 to be 36 times 2. Breaking that up by simplifying, I have root 9 times root 2 plus root 4 times root 2 minus root 36 times root 2. Note that each of this factor pair is made up of a perfect square. So therefore we have root of 9, that's 3, root 2 plus root of 4, 2 root 2 minus root of 36, 6 root 2. And simplifying, we have 3 root 2 plus 2 root 2, that will give us 5 root 2 minus 6 root 2. We have minus 1 root 2 or minus root 2. Thanks for watching. Bye.